arithmetic series, we're constantly getting larger by some kind of addition property. So check out these rows of seats that we're setting up. And a lot of you guys set up seats in like form and those different things. We see 4 in the first row, 5 in the next row, 6 in the next row, 7 in the next row. So we want to know if we've been asked to set up 20 rows of chairs, how many chairs will there be in all 20 rows? Now last week or 2 weeks ago before break, what we talked about was how can we, Ben, what'd you do with the rest of the notes?
Dude, I gave Robert, oh my
Wonderful.
God.
This goes back to elementary school. Please pass one back.
Yes, sir.
So, how could we figure out how many chairs are in the 20th row? Not the total amount of chairs, but how many chairs? Yeah.
You are looking at me, right?
Yes.
Okay,
Was that a
because
hand
the
raise?
reflection gets over your glasses and I can't see where your eyes are going. Yes. Couldn't we just do like the number in the first row? And since we're only adding 1, we could just do 20 plus 4.
Yeah, so that formula that we should remember from last or 2 weeks ago or whatever was like the amount of something in the nth row is going to be my starting value plus that common, what did we call it? It's not a ratio. If we're arithmetic, it's a difference, right? What letter did we use for that?
D.
D. So the difference times how many times it happens. Now to go from row 1 to row 20, how many times will we add that 1? 19, right? So this we kind of say n minus 1. So a sub 20 would be my 4 rows, or my 4 chairs in the first row, plus my difference of 1. That happens 19 times to get me to row 20. So it's really just 4 plus 19. So 23. Okay, but that's still not my answer. What I'm wondering is how many total chairs I have to have. So I could do 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 7. Get really annoyed.
Wait, no, I don't.
But it'd be fun. Anyone know an easier way? We talked about this with the Einstein problem. At least I think it's Einstein. It's just a math story.
So, what I would do, so you know that there's a base of like 4 in every single one of these rows. So I would do 4 times 20, and then you're adding up the first. So, no, I would do 3 times 20, and then you would have 1, 2. So it would be like 3 plus 1, 3 plus 2, 3 plus
Yeah.
4,
Okay.
3, and then so on. And then you would do the 1 paired up with the 20, and then so on.
We're looking for an easy one.
2
We're looking
with
for
the 19.
We're looking for an easy way. I agree that that could work, and we could use a factorial there. Well, kind of we could use like an addition factorial, which isn't. It's not really factorial. But we can think of it like that. It's not that easy though. Who remembers the Einstein story about he got in trouble by his teacher? His teacher thought he'd give him a. What was it?
It was like, you had to figure out, was it 1 to like 1,000 or something?
Yeah, 1 to 1,000. His teacher was like, "This will take him forever."
I don't know, but he
What was
just
the
paired
question?
up like 2 numbers, and then
What 2 numbers?
like 999 and 1 to make 1,000.
Then
and
what would
just
he-
make groups of 1,000 and then add them.
Yeah, I can group my first value and my last value and get the sum and know that if I shift in, if I add 1 and take 1 away, I'll get the same value. Add 1, take 1 away, you get the same value. Add 1, take 1 away, you get the same value. So really what we're going to end up doing here is figuring out what's the sum of the first row and the last row, and then how many pairs am I going to have. So really, don't know if it actually gives you the formula here. How many chairs in all 20 rows? Yeah. Didn't really give the answer.
maybe it expected.
Yeah, so
Because it knows Mr.
What's the answer?
we figured out there's 23 chairs in the last row, right? We know there's 4 chairs in the first row. How many pairs of rows can we make if there's 20 rows? 10 pairs, right? So if I pair up my first and last, I get 27. If I pair up my second to first and second to last, I get 27. Third to first, third to last, I get 27. So we really just say there's going to be, so I'm going to say like just total will be a sub 1 plus a sub 20 in this case, or you could say like a sub last or whatnot, times the number of pairs, which we're going to have a technical formula that we're going to use. But for right now, just reasoning through this, thinking about the Einstein problem. So what we have is 27 times 10 pairs of rows. How many seats do you need? 270. And if you did 4 plus 5 plus 6 plus 7 all the way up to 23, you'll get that value. So really, the formulas that we use for this, and I had my notes in somewhere. This is also like normally those launch problems are they're described in the very next thing, like how to solve it. So this is a very important formula. If I was you, I'd probably write it on my note card right now. This is a finite. What's it mean to be finite?
Very small.
No.
Passed it back to me. You didn't have it.
What? Okay, what does it mean to be infinite?
Hard. It never ends.
It has no end, right? We can't even count it. It's not obtainable. Finite. It has an end. I need my series to end so that I can pair up rows. If it doesn't ever end, I can never pair things up. So that's why this is important, that it's a finite arithmetic series. So we essentially take how many rows, or in any case, how many terms do we have divided by 2, times first term plus last term, the sum of the beginning and the end. Questions on how that formula works? And a sub n, of course, they're using as their last term, because they say you have n number of terms. N is the number of terms. So a sub n will, of course, be your last term. Summation notation. This isn't really going to make sense yet, so just hang on to it until we get to it, and you'll flip back probably. When we talk about summation notation, you know what Greek symbol we use for that?
Eta.
When you're about to write.
Sigma, which that doesn't look like a very good sigma. If you want a really good sigma, they have like little, Greek letters are really kind of weird. But sigma is what we use to represent a summation of items. So we have this series, and we're going to run through the example problems quickly and then take a little bit longer. So if we want the sum of the integers, what do we know if they're integers, even integers? What's the common difference? If they're even integers, my common difference is going to be 2. How can I determine how many terms I have? Is it 50 or 49? I mean,
49. Well, you find the difference and then you divide that by 2.
I'm going to divide 2 by 2.
No, you find the difference between the lowest and the highest.
Okay, so the distance they have to cover, so not the common difference, but the total difference.
Yeah.
So what Greg is saying is from 2 to 100 is really 98 places, but we didn't take all the places. We only took every other. That's why my common difference is 2. So we divide by 2. Do we get 50?
No.
49. Now wait a minute. Does that account for the first term and the last term?
Yes. Nope. Yes. Yes, it does not.
No, it doesn't. No, it doesn't.
How does it not?
Because it doesn't.
Because you have to add one more. Because when you talk about difference, you're always leaving off where you started. Because when I talk about difference, that 2, that original number, does not apply in how many terms. Because really what you did is how many moves did I take. From 2 to 100, there's 98 moves. But if I count the 2 and I count 100, there's really 100 values. Or, well, 99 values. But how many shifts do I take? I have to add one more. So really, we take 49 shifts. Because I want you to understand. You with me? I take 49 changes, but if that's one change, I really have 2 terms. So my second change, I've already counted this term. My third change, I've already counted this term. My fourth change, I've already counted that term. So then I only have 1 more. But if you take the method that you were talking about, Greg, you just have to add 1 more to it. Okay? That's how we get the 50. So I like what you said. Find the total difference and divide by 2. But then you have to add 1 more.
Wait, what?
You add 1 more to account for the first term
Yes, so wouldn't that be 49?
plus 1 more. You took 49 changes.
I took 48.
So, check this out. I want to find out how many steps I take. 1, 2, 3. How many times did my foot hit the ground? 4, because when I started, on the ground, on the ground, on the ground, on the ground. But if I only count the steps, I don't count the first foot that was on the ground. That's the difference between how many changes and how many terms. Does that make any sense? Okay, I'm going to move on because you're not focusing. So, we find out how many terms are in the value. There's 50 terms. Guys, I need to separate you. Because the little murmur is not helping anyone. If you have questions, ask me. Take the number of terms, divide by 2, and then multiply by your sum.
Oh, I actually have to take this. Can I please take it?
Who is it?
It's Kroger.
Why is Kroger calling me?
An interview.
I have a phone interview.
Hello? Constance, Greg is a wonderful student, but he is actually in class right now, so I'm going to have him call you back if that's possible. All right, thank you very much.
Thank you.
You can't take phone calls in class. Yeah.
I need to take this call. From
Try the guide on your own.
I thought that was your mom or something.
Oh
Nope,
my
it's Kroger.
You're a great student. I didn't schedule it.
This is a good
I
point.
scheduled it for like later. I scheduled it for afternoon. It's definitely not. Well, afternoon is like 12:01.
Yeah, actually. I want people to think of us. Yeah.
No. It's still
I know. It's scheduled for afternoon.
Guys, I have to
Wait, how many?
Greg, I'll write you a personal letter of recommendation if you need, but you're not going to take a call in my class. So when we talk about going from 4 to 99, let's use Greg's method, because that's how we want to do this. What's the difference between 4 to 99? 99 minus 4, 95. What is the common difference between my values? 5. So I take that, I divide by 5. 95 divided by 5? 19. But because I also need to count where I started, I add 1 more, and I have 20 terms. Anyone find the sum yet?
So where's the 5 come from again? Oh. Yeah,
So you
okay,
take
got it.
the total difference divided by the common difference. Then we add 1 more to account for the first term that we did not deal with.
Yo, Mr. Hudson.
Yo.
Alright, so in the problem before this with the 50, 49, and all that, so then below that it's like 50 divided by 2 and then it has the whole thing and lower than afterwards.
The problem, you're talking about problem 2? Or problem 1?
Problem 1.
Yeah, so they just didn't work through the how many terms because they tell you the 50th term, they tell you how many terms there are. But if we have to determine how many terms there are, so to determine the number of terms, and you may want to write this down somewhere. I take the total difference. Now this only works for arithmetic, right? Because differences deal with arithmetic sequences. Total difference over the common difference. And then add one more. Because total difference over the common difference will only tell me how many changes I've made, how many gaps between the terms, find out how many number of terms I have to add one more to compensate for that first term not being counted.
Yeah, I get that.
Okay.
What I was asking was, it says like after that, since we did all that to get 50, right?
Mm-hmm.
And then after that, in the bottom thing, it gives you the whole formula. It has 50 over 2. So why does it?
That 2 does not, it's not because the common difference is 2. That 2 is because I'm pairing my terms. So instead of having 50 pairs, I have 25 pairs.
Okay, thank you.
Yeah, you're welcome. So, then we take the sum, I forget how we notate this, just S, I think, yeah, S sub the 20 terms. So S sub our 20 terms will be the 20 number of terms times what? Nobody's going to catch my mistake.
You have to
Gravity works.
You have to divide.
The 20 has to be divided by 2 because it's not 20 pairs, it's half as many pairs. And what should be inside this parentheses is the pairs. What do I pair up? The first and the last, so 4 and 99. So this really becomes 10 times 103. So the sum of those 20 terms will be 1,030. Hey, I think she said they're open until 6, by the way, which is weird, but maybe it's their office is only open until 6. What Kroger? The one up on Sawmill? You're applying the one on Sawmill?
The one at the Worthington Mall.
Oh, good. I don't go there. I'm joking. You guys know Kyle? You guys know Kyle Cunningham?
Yeah.
He works at that Kroger, and almost every time I go to Kroger, I see him. I'm like, hi, Kyle. He's like pushing carts or something. All right, so
A sub
down by Kroger.
now we deal with real situations. Greg, you're very close to finding a new desk. A company is going to pay a $10,000 bonus to salespeople at the end of their first 50 weeks if they make 10 sales in their first week and then improve their numbers or improve their sales by 2 each week thereafter. One salesperson did qualify for the bonus with the minimum possible number of sales. How many sales did the person make? So don't just breeze over this because it's shown out for you. Like I have this all shown in your notes. I get that. But we want to think about what are we doing and why. So I know that my first week has to have 10 sales. I know that my difference, I have to gain 2 sales every week. So to find my last week, I'm just going to take my A sub n formula is my first term times n minus 1, because remember we only have how many shifts, the terms minus 1, times the common difference. When we wrote this earlier, I wrote the D in front. It doesn't matter whether your D is in front of the parentheses or behind the parentheses. It will do the same thing. So we know that there were 50 weeks, or 50 terms. So we do 50 minus the 1. We end up with 10 plus 49 times 2. So we see that the final week, I should have 108 sales in that last week. Any issue with how we get there, because that work was before spring break. I know that was a while ago. This formula I would also have on your note card, but you want to make sure that you recognize what it is. That's finding your final term. So when you're finding your final term, that's our formula we use for an arithmetic series. If I was you, that note card, I have one side for arithmetic and one side for geometric. That would just be my suggestion so you don't get confused.
Yeah, really.
I don't know about brilliant, but I sure do try.
Okay, fine.
So then, to find our sum, this hopefully should be on your note card. Formula that we've seen a lot today. Number of terms divided by 2. Then times the sum of my first and my last. How many terms do I have here? Well, how many weeks are there? 50. Right, yeah? Yeah, 50 weeks. How many terms does that make us have? Makes us have 50. If it's 50 weeks, there's 50 terms. A term from the first week, a term from the 50th week. But that, just 1 to 50, if you count all of the numbers, there's 50. Because we're starting at 1. It's pretty easy. So we do the math, and we find out that in total, they will have had to make 2,950 sales. Which this is one of those situations where your company might say, you have to improve by 2 every week on average. Maybe one week you didn't improve by 2, but the next week you improved by more. Guys, do I really have to remind you of the elementary rule of if it's not yours, don't touch it? Questions on this one? How we did this, why we did it.
I just have a question on why a company would do that.
Incentive. Because if you just say you need a dozen sales every week, what's your incentive to get better? What's your incentive to sell more for the company? If you don't make commission, who cares how many sales you have? I just want a job. I just want to get paid. But if I have incentive to keep selling more products or whatever it is, I'm going to keep trying to get that because I want my $10,000 bonus. That's huge.
I was thinking it should just be like a total number of sales you have to make extra.
Yeah, well, this might be on average. And they would, I mean, they like to start easier to give you that confidence of like, hey, your first week goal is only 10. That's it. Like you're getting your feet wet. You're learning how to do this. Then as you get more experience, we want you to perform better and better and better. Yeah. This is just one example of how companies are structured. Try this on your own. $5,000 bonus. Does this $5,000 bonus matter in the math that we're going to do?
No.
Well, let's look at what it's asking. How many sales were in week 50? And then how many total sales? That $5,000 doesn't have anything to do with it. That is a distractor. Watch out for those numbers that they're going to put in the problems that you don't need. Be careful of the distractors. So what we care about is 50 weeks, 10 in the first week, and improve by 1 sale per week each week. So to find my A sub 50, what do I do? Well, I'm going to write down my generic formula first. A sub n is going to equal A sub 1 plus, and you know, I really like to put the difference first. I don't know why they write it last, but I just really like to put it first. So it'll be the
Doesn't really make a difference.
ha, ha, ha.
We always laugh, but
That was amazing, Jake.
Is that weird laugh?
Okay, that was
That's literally Jacob's laugh.
That actually really sounds like the beginning of a Gorillaz song.
what?
Well, if we have time, yeah, you know what I'm talking about. So this becomes A sub 50. My first week, I need 10 sales. My common difference is 1, because I only need to increase by 1 sale each week. How many weeks? 50. So I'll do my 50 minus 1, because I can't increase in the first week. I can only increase after the first week. So this really becomes 10 plus, or
Yeah. That's 50.
yeah. Sorry, this is just smaller than I anticipated, because last one, when you only have a difference of 1 versus a difference of 2 or 3, even though the difference isn't that big, your end result will be quite large, because 50 weeks, that makes a big difference. So we get 59, right? So in the last week, I'm going to make 59 sales, hopefully.
Oh my god, that's a lot. A lot of stuff. Is that one person?
Hmm?
Is that what is that?
We don't know, that's the thing. We don't know what they're selling.
they're selling.
They could be
Yeah.
selling bags of
That's not
peanuts.
car sales. You ain't selling
They're
peanuts in cars.
They're selling beans.
Dude, what if you looked at the
They're selling airplanes.
Sum of n terms. What's my formula there? We always want to start by writing the formula.
There's an n
There's an n and then a.
N divided by 2.
Yep, my number of terms divided by 2.
Parenthesis A1 plus AN.
My first term and my last term.
That's it.
Hey Ben, you're really close to getting a new desk. So my sum of these 50 terms is 50 weeks divided by 2. What was my first value?
10.
Yeah, 10. What was my last value?
59.
Yep, that's why we just calculated that. This will give me 69 times 25.
I think it's more than 4.
I would agree. 1,725 would be the total sales that you will have needed to make.
That's a lot more than 4.
So what?
It's less than 4, obviously.
I should say. That line I made harder for you to concentrate.
And there it is written out their way if you want to see that one. Captured in the notes.
Like your way was easier.
Because I try to make things easier. Always many right ways to get to Florida. Alright, now we get into summation notation. This is where sigma comes into play. So the weird E looking guy, and no it's not an E, do not call it an E, it is sigma. That's its name, that's what the symbol represents. That's why, so our Friday schedule, alpha, beta, gamma, delta, those are the first 4 letters in the Greek alphabet. Sigma is another letter in the Greek alphabet.
Is that the one for S?
It doesn't, there's not like a direct conversion.
Alpha,
It's close.
Beta,
Gamma.
gamma.
And gamma's weird. Gamma looks like that. Yeah.
Yeah.
What's up? Okay, thanks. So, here's where your life gets a lot easier. Grab a calculator.
Yay!
That's what I'm talking about.
We gotta hurry up to get to it, so grab your seat again.
That makes much more sense.
No, that's not. Yeah, those are just All right, so if you go back to your summation notation, we'll just go back to here. Who can guess what we're really doing here? If you see, all of the sigmas have n equals 1 at the bottom. That below your sigma tells us where to start. What do you think above the sigma tells me? How many terms I go. What do you think in the parentheses is?
The difference and your starting.
Yeah, how I write out that series or that, that series. So when I look at this series, would it be 7n? Would it be 4n plus 3? And then I'm going to have to figure out how many terms there are. So what if n is 1? What should my value of a sub 1 be? In this series, what is a sub 1? It's the first term up there. 7. If I plugged in n in either of these, 4n plus 3 or 7n, it would work. So check a sub 2. That is 11. If I plug a 2 into here, that will not work. We immediately get rid of both of these. Because when I plug in n equal to 2, my second term is 11. 7 times 2 does not give me 11. That is not the correct notation for the series. So we know 4n plus 3 represents my series at term n. So now I just need to figure out are there 50 terms or 51. So we can use Greg's method.
Or we can just, so we know 51 will be the last term, so or 50. So we can just plug that in.
Yeah.
So we could just plug in either 50 or 51. So if I say, what is a sub 50? Then I can plug the 50 in for n. 4 times 50? 200. 200 plus 3? 203. So does my series end at term 50? No, it ends at term 51.
Which is the one you pointed at.
And if I solve a sub 51, I will get 207. So now we could take that, drop it in our calculator, and it will do all the work for me. And I'm going to show you how to do that in just a second. Find your summation notation for this. You know your a sub n. You know your a sub 1. So we know we're going to start with sigma. N starts at a first term. We almost always start at the first term. Sometimes, if we only want to look at a chunk of the series, we sometimes won't. I got to figure out how many terms I have, and I have to figure out the notation of this series. Sigma means summation. That's just mathematically, sigma means summation. It adds up all the terms. So summation means add them all up. Yeah. How do I write my expression for that series? Well, we know we start somewhere, and we know that we move somehow. How am I moving from one term to the next? Adding 7. So now it's going to be 7 times n plus where I started at. So, do I use -5? Right? Because if I use -5, that won't work when I plug in n-1. So what do I actually have to do? -13. I have to go 7 down from my starting point to accommodate for this n-1, or like the n being in here. Or the only other option is we could do 7 times n-1 plus that, but that gets complicated. So we might as well, because if I do, just to show this really quick, if I did that and then I distributed, then I'd get 7n minus 7 plus -5, and I'd combine these and I'd get my -13, which is the exact same thing.
Yes.
Sorry, you're correct. 12.
You don't do.
Sorry, quick math. You make mistakes. It's okay. So really, ignore all the extra work and just do it on your own to begin with. So now to figure out how many terms we have, I can't just do like a plug in an n, because I don't have any multiple choice. I don't have any suggestions, so I don't know what n's to try. So this is where Greg's method will work amazingly well. Huh? It does work.
Only every once in a while.
Difference between -5 to 268. Well, since I started a negative, really added on 273. What do I divide by there? 7, right? Because that's my common difference. Calculators, 239. So how many terms do I actually have? 40, because I have to add 1 to accommodate for that first term. So I know that my value that goes on top of the sigma, my final term, is the 40th term. Any questions on how we do that? The difference between -5 and 268. Yeah, because I start at the negative. All right, last thing we got to do today. How you make your life easy.
Win the lottery.
Yes, but... So we can use our formula here. You have this shown out on your paper, so I'm not going to take time to show it. You have your formula. You could apply your formula knowing that your first term is a sub 1, your last term is a sub 70. We could plug in the values to find my first and my last value. That's what we did to find my 8 and my 353. And then I just use the math that we know. But instead of doing all this, we're going to skip B for a moment, just because we don't have a lot of time left. Actually, I want to show you the answer for B if you want to go back in the notes. That's the long process that we could take if we only have a short series. And especially if we have something squared, we just list them out. Because I only have 7 terms in that series. So if you want to go back and look at this. Yeah, I'm going to skip this also because we're running out of time.
Skip everything.
No, we got to see how to do it in the calculator. So in your graphing calculator, here's what you want to do to get to your summation notation menu. Math menu is always your best friend. So you should, and I left my calculator at home
I
today,
can't
actually.
find my best friend.
It's the button that says math.
I don't have any friends. I don't have any friends.
What site?
I live in a cardboard box.
Crap. I'm using my other calculator. Anyone find this yet? Anyone going through the menus? Hit second stat.
We always got it.
Second stat. Second stat will get you to this menu because really we use summations in statistics. So that's why we go to the stat menu. Hit sum. It'll drop sum out to your main screen. Go back into the second stat menu. But now you go to operations. Notice here, this one was math. This one was operations. So now we tell it we're doing a sequence. Then I put in what my notation is. 5n plus 3 in this case, because 5n plus 3, that's my notation. And then I tell it my value that tells me the number of terms is n, then my first term, then my last term. So you have to tell it what's the expression for the series, what is your variable being used. I know your calculator, you have to tell it all this stuff. Then your first, and then your last.
Yeah, how do you do n?
So your x button, you can use x if you want. Then you just tell it your variable is x instead of n. So you can get to n. It's like in the menu, but I just use x. So just do 5x plus 3, comma, which remember comma is right above the 7. Then hit x as your variable. Then your first value is x equal to 1, comma, your last value is the 70th term. End, do your parentheses. How many parentheses did you open? 2, so we need to close 2. And we should get 12,635. As long as you understand how to do this in a calculator, that's all that matters. You do not need a calculator. We can always do this. Greg, now that you're on lunch, hey, now that you're on lunch, you probably think it would be awesome if you all did that now, even though it's your work day. Alright guys, so I will not be here tomorrow or Wednesday. Please do go for the guest teacher.
Oh God, we're learning something with the guest teacher.
Don't worry, they're a math person. Alright, have a great day.
Dang it, I want another mind teacher.
John, we had a 22 score.